Everyone, it's Laura. Hope you're doing well. And in this video, I'm going to explain nested for loops in Python using a short Python program I created called NBA G.O.A.T Debate Settled. Before I demonstrate my program and explain the code, keep in mind at a high level, a nested for loop is simply one loop inside of another. Nested for loops are typically used for working with two dimensions, such as printing stars or symbols in rows and columns. Now, in my example program here, I'll print my favorite player's name in rows and columns. Let me go ahead and demonstrate this program. Who is the greatest player of all time? I'll enter in my favorite player, LeBron. How many rings does this player have? 4. How many seasons has the player played? 18. Now, you see here the output of the program prints LeBron's name 18 times in 4 rows. And the last line of the program says LeBron is the greatest player of all time. LeBron's GOAT score is 72. So now let me go ahead and walk you through the code for this program. So our program starts off by initializing the variables player, rings, and seasons based on user input. We want to use the integer function in Python to convert the value of the user's input to an integer. Now this is important because we will, later in the program, we're going to go and iterate through both of the rings variables and the season variables. Now the variables stored as an integer also allow us to calculate the GOAT score based on a product of the player's rings and the numbers of seasons. All right, so let's move down here to the nested for loop. Now keep in mind, when a loop is nested inside of another loop, the inner loop must finish all of the iterations before the outer loop can continue to the next iteration. Now you may ask why the variables I and the variables j have been used. Well, since you're indexing a for loop, you use I to represent the index. I is simply a variable. But if you nest a for loop inside of another for loop, the second for loop needs a variable as well. Now we can't use I because it is already in use. So what most people use is j. Now there's no rule against what you want to name the variables here. It's just a coding norm to use I and j. So in Python, using a for loop with the range function, we can repeat an action a specific number of times. So to represent rows, since LeBron has 4 rings, our program will print a total of 4 rows. Now in computer programming, indexing counts always start at 0. So in Python, when you see the range function used in this way, 4 technically represents the stop value. So starting at index 0, going up to index 3 is a total of 4 rows. In other words, starting at 0, we're going to iterate through all 18 seasons of LeBron's career and print the player's name each time for that row. Now, as you see here, using the end equals quotations, after executing the print statement, this will prevent our cursor from moving down to the next line each time we print LeBron's name. Now, if here you see an empty print statement. So in Python, it allows us to print a new line after exiting the inner for loop. So this empty print statement exists within the outer for loop and tells us to print a new line only after LeBron's name has been printed 18 times. So after the empty print statement prints a new line, our code goes back to the outer for loop. Now our I variable, which started at 0, is now pointing to index 1, which is the second row. Now we'll again move to the inner for loop and print LeBron's name 18 times. Then we'll exit the inner for loop, and the I variable will now point at index 2, which is the third row. As you see, the pattern continues until LeBron's name has been printed for a total of 18 columns in 4 rows. So this is why nested for loops are often referred to as having an algorithmic time complexity of O of n squared, which I'll explain in later videos. Now, moving down to this last print statement. The last print statement is not part of any of the for loops. The F string notation, which you see here, simply allows us to embed expressions inside string literals. So this allowed us below to print on the last line of the program, LeBron is the greatest player of all time. And then the player expression, LeBron's GOAT score is 72. And as we see here, the formula I came up with is that a player's GOAT score is calculated by multiplying the rings times the seasons, or simply put, the rows times the columns. So this was just a fun way to demonstrate nested for loops in Python. So obviously there are various aspects of a player's game to consider the greatest of all time. Now just for fun, I also calculate the value of other players' GOAT score. And another surprise from a basketball perspective is Tim Duncan. He was actually my favorite player growing up before LeBron, and he actually inspired me to play in college and professionally. So I know that, Tim Duncan's name doesn't come up a lot in conversations of the greatest of all time, but I was still surprised by his score. So if you do have time in your spare time, you can make this program or you can just calculate it yourself. But Tim Duncan actually played 19 seasons, and for some reason I thought it would be closer to 16 or 17. I don't know why. But based on that, Tim Duncan's GOAT score was actually 95. And surprisingly, Jordan's GOAT score was 15. He played for 15 seasons, 15 times 6 was 90. So I was actually surprised that Tim Duncan's GOAT score was that high. So again, of course, we all know that there are a variety of other factors that, each fan holds dear in their mind of what makes a player the greatest player. But for me, the take-home point really is LeBron's work is still not done. History is still being made, and his GOAT score will continue to decrease, over time. So from my perspective, LeBron is the best player I've ever seen. However, I do respect all the players who are in the conversation and all the greats before LeBron as well. So if you found this video helpful, please remember to like, subscribe, and comment. Thank you.